Good evening, ma'am.
Good evening, dear.
Good evening, ma'am.
Good evening, ma'am.
Good evening, everyone.
Good evening, ma'am.
How are you all?
Fine, ma'am. How are you?
I'm also fine. So, did you try that distance time graph?
Ma'am, yesterday, I couldn't submit my subjective test, so can I send it today, ma'am, in the PDF form to you?
Yeah, okay.
I'm okay.
Ma'am, when will we get the subjective test mark?
By Wednesday.
Okay, ma'am.
Put on your cameras, everybody. Turn on your cameras. Everyone. Hamza, Rishit, Rohini, Siddhant, Sriyansh. This is not something to be asked every day. So we have to work more upon distance time graph, okay, because most of the students didn't understand that day also. So today we'll try to make it clear. Basically, if I say what is a graph, it is just a representation of data which makes it easier to understand in just a single picture. If anyone tells you verbally, or if someone makes a table, you have to look step by step, step by step. So definitely if we compare the tabular representation verbally, so just forget that, we can understand, right? Tabular form comparative to graphical form, where we just, look by the line of graph. If it is straight parallel to x or y axis, if it is straight slanting upward or downward, or if it is curved, it gives a brief, good idea about the things the data means. If whatever quantity is there, it is rising, it is at rest, or it is reducing, or whatever. So basically, in this chapter, we are just drawing the distance time graph. Fixed quantities, always distance to be on y-axis, time to be on x-axis. Because on x-axis, we usually take the quantity which is, which regularly increases and like keeps on repeating itself after a fixed interval. I'm sharing the whiteboard. Hold on. I'll be drawing few graphs, and you have to tell the nature of motion. Okay. Sorry. Second is, third one is, so read the graphs first of all and tell me something about them. What kind of motion are they depicting?
Ma'am, first one is non-uniform.
First one is non-uniform.
Now, first one is uniform motion.
Okay.
Ma'am,
And,
second one is uniform.
Ma'am, rest all are like non-uniform.
Ma'am, second one is in rest, I think.
Okay.
Yeah.
Great. Good.
Ma'am, and rest 3 and 4 are non-uniform.
Non-uniform.
Ma'am, non-uniform.
Yes, ma'am.
Fine. So those who are able to understand this, very good. Now let me tell you how to read the graphs. First is, see, I have not taken any values on these so that in general you can have a good idea. Time is on x-axis, and we know like time always increases by successive intervals. It will keep on increasing, right? So according to the time, like if you keep moving, look at the blue lines, which are different. First is slanting, straight slanting upwards. Second is straight but parallel to x-axis. Okay. Third is curve that is like increasing gradually. Okay. And fourth one is first increasing and then reducing. We can say overall it is reducing only. Means up to a
Yes,
very
ma'am.
little extent it has increased, and then further it will be considered decreasing. So with the time, if I, mark time values on this, first of all, do one thing, please do all these graphs, because I'll, annotate on the screen and write a lot more, then it will not be easy to note these graphs. Just draw these graphs. Later on, when I'll tell the nature of graph, the names, then you can add it on. Without any marks, please draw them.
Ma'am, like the second object describes like the car or the object is moving in the same like it is continuing with a constant speed there.
Second,
Yeah, ma'am. Second one.
that's the center.
Ma'am, I have a doubt.
Mhm.
Ma'am, in like yesterday's All India Test Series, like there was a question something related to displacement.
Hmm.
So, like, what is displacement?
Okay, fine. First, let's finish up graph. If I start
Okay.
displacement in between, we can neither cover distance time graph nor cover displacement. So wait.
Okay.
Just after I complete these graph explanation, please remind me once again to explain the displacement.
Okay.
Everyone drawn the graphs?
Yes,
Ma'am,
ma'am.
one second.
Ma'am, what is the second
Ma'am,
diagram?
I'm drawing one.
Here, please wait, I'll explain. Those who are asking the second one, wait, please. Now done? Seventh class, is it done or not?
Ma'am, it's done. Ma'am, 1 minute.
Be quick, please, in noting down the stuff. We do not waste this much of time. I hope it's done now.
Yes, ma'am, it's done.
Now, if we, mark the points on time axis and just by an idea, look at the values of distance corresponding to the each time value. You will note that the change in the distance values is also uniform. The time values are obviously uniform, the distance change in the distance values is also uniform. So it means distance is changing at an equal rate as that of time. So very clear, this first uh, graph shows the motion, uniform motion.
Yes.
Now, similarly, if I mark the equal interval values on time axis and correspondingly look at the distance values, can anyone tell me what it is showing?
Ma'am, it's equal.
At every
Ma'am,
time
it's
value,
equal.
the value of distance is same.
Yeah. When the distance is same, but the time is keeps on.
Time keeps on increasing, but the distance value is same, neither increasing nor decreasing. If the distance
Because that the vehicle is in rest.
yes, the object is at rest, no motion. Yeah. Zero speed. Next, third. Now, if we look at the third, by marking the points on time axis and correspondingly look at the distance values, you can do the same thing with the help of a pencil, means by not making, much changes in your graphs, because this is just for understanding. If you see that gradually time axis has the equal time interval, time gap, and correspondingly, if you look at the value of distances, first it was increasing, at a smaller rate, then it started increasing at a large rate. Means, can you see the gap? So gradually it is increasing. The distance is gradually increasing, not uniform rate. We cannot say this is uniform, right? So this type of motion is This type of motion is
Non-uniform motion.
non-uniform, definitely. But what about the speed? Any idea about the speed?
Ma'am, like the speed would be changing.
Definitely changing. We can say it is increasing. Okay.
Yes.
Speed increasing gradually. And similar thing if you do on this one, then you will find this is also non-uniform and the speed is gradually decreasing. Fine.
Shouldn't we keep the arrows like to denote whether the speed is decreasing? Because the thing is like from the starting it may practically if you see from the starting also it can increase. So can't we keep an arrows for non-uniform for that blue color light or something like that?
Arrows, you mean arrows where the speed started decreasing?
Yes, ma'am. Like it is when we see from here, it is looking like it's increasing, and it is looking decreasing also. It is looking like increasing also. So, but the both ways because they start from the 0 point. So I'm saying that can't we keep an arrow to denote whether it's decreasing or increasing?
Now look, it is still not clear to you. See, the time values are at the equal gap, means equal change in time interval, and look at the corresponding values of distances. See the change in the value of distance, okay? For next also. Means first the distance covered was this much, then the value of distance decreased, further decreased. Have you understood now what I mean to say? That the
Yes,
distance covered in the first, let's say this is 5 seconds. In the first 5 seconds was maximum distance covered. Then in next 5 seconds, the distance covered reduced. Suppose first he covered in 5 seconds 100 meter. Then the value reduced to 80. Not
80.
80, but it seems 70 only. Okay? After 70, it seems 30. After it seems 5. So gradually the person is decreasing the speed. That's why the distance covered value is reducing. Are you getting? You are just looking at the blue line. The blue appears to be increasing. Don't go on the line. Try to analyze the data as per the distance value. Are you getting?
Yes, ma'am.
So this is the mean. I know looking at the blue line seems that it is increasing. The line is seems like increasing, but the distance covered is not increasing actually. So do one
Okay.
thing, everyone. Do one thing. This will help you later to understand the graphs better. Take a pencil and just put equal marks by an idea only. Don't write any values. It will be easy to understand how we used to read the graphs, how we used to understand the change in the distance and time values and decide what type of motion they depict. So use pencil for these dotted lines that I have also done. Do it quickly. Here with the distance you can write equal rate, change equal rate. Here the distance has the same value. That's why the object is at rest. The distance is, I'm writing gradually increasing. Do not write in the exam or any test, whatever I'm writing now with the maroon pen, right? This is just so that we can understand it better. Gradually increasing. Because I'm writing it near to y-axis, this means I'm writing about the change in distance values only. Because time interval I have already taken the same intervals. Gradually it is increasing and gradually this is decreasing. I hope no more doubts in graphs now. To how to read the graphs.
Ma'am, like in the uniform motion, the speed is going to increase.
Sorry, pardon please. Can you please repeat?
Ma'am, in uniform motion, is the speed gonna change? Like,
Your speed is not changing. Speed is fixed. That's why it is uniform. And how we say that speed is fixed and speed is uniform? Because distance is changing at equal rate. It's, I think you people have not gone through the definitions and while we were discussing uniform and non-uniform motion. So that's why please be attentive and join the class on time so that you do not miss anything. Speed is uniform or non-uniform will be decided by the change in the distance values, because the formula of speed is distance upon time, and time always changes at an equal rate. And if you are taking time like 5, 10, 15 seconds time, already you have taken equal rate and you are observing the motion of object after every equal interval, let's say after every 1 hour, after every 10 minutes, etc. Accordingly, look at the change in the distance values. It will be easy to decide the object is at rest or uniform motion or non-uniform. Should I clear the annotation?
Yes,
Yes,
ma'am.
yes, ma'am.
Ma'am, you told that. Ma'am,
Uh,
you told you'll explain about displacement.
Sorry?
Ma'am, you told that you'll explain about displacement.
Yeah. If you have noted, I'm clearing it out. Okay.
Yeah.
Although displacement is not in grade 7 syllabus, but it's okay. Something extra is always great to learn. Distance, everybody knows. Distance is the, you can say, if we are riding a bicycle and we go to market and back to home, so how much ground we have covered by the cycle? In very simple terms, this is okay. Distance and displacement are somehow similar, but not same. My home is here and the market is here. And I do not have the direct way of traveling. Okay, I have the direct way, this, let's say this, I can go by straight road. But I had to meet one of my friend. Okay, my friend lives here. So I decided to follow this path. After meeting my friend, I went to market and then came back from the same path. Now, and what my sister does, my sister, she chose this path because she had less time and no extra work and no meeting her friend. So she went this way straight and came back, early. And we had to buy the same stuff. Suppose we were on the shopping for our clothes. That's okay. So she follows this path and come back in the same path. Now, let's say the distance of my friend's place is, how much should I keep it? 2 kilometer. It is, let's say 2 kilometer. This seems also 2 equal distance. And from this to this, okay, we will find it out. I've covered 2 kilometer, then 2 kilometer, and back on the same path. So what distance I have covered? This is 2 kilometer plus 2. This is up to market, then 2 back to friend's house, then 2 back to my own place. So overall, 8 kilometer distance I have covered, right? Now, okay, the distance that my sister has covered. Can you, you people know what is Pythagoras theorem? Do you people know what is Pythagoras theorem? Anyone?
hypotenuse something.
Yes. If we have a right angle triangle, like here we have HF as the base of triangle and FM as the height of triangle, then the side opposite to 90-degree angle, that is the vertex F, opposite to this HM is the hypotenuse. Okay. Just simple terms, understand. The theorem says hypotenuse means the side square equals to base square HF square plus FM square, where HF we are calling base and FM I am calling, okay, this is height I'm calling, let me say call it perpendicular. I'm calling FM as perpendicular because H stands for hypotenuse, right? These are all distances. So I can calculate the distance of hypotenuse, base square 2 square, P square, sorry, P square is also 2 square. How much it is? 4 plus 4, 8. Now if H square is 8, H should be equal to root over 8. Do you know what is square root?
Yes, ma'am.
All of you knows or no? Be open.
Yes, ma'am. Yes, ma'am.
Okay. So this means, or I'm writing this way. 8 power of 8 is 1 by 2. Can you tell me what will be the value if I take it out of the root? It should be 2 root 2, right? And the value of root 2 is 1.4. I'm just writing 1.4 approximately. Okay, let's not make it much complex. The distance is 2.8. So my sister has covered how much distance? Only 2.8 kilometer. 2.8 kilometer. So this 2.8 kilometer is the displacement. What you have understood out of all this, can anyone explain? And I guess Siddhant, you were asking displacement. Who was asking displacement?
Ma'am,
I'm
me,
a
ma'am, Rishit.
Rishit. Okay. What have you understood? What is displacement?
Ma'am, like, is it the hypotenuse, like,
Ma'am, the shortest part covered from the point H to N.
Between any 2 points, suppose you are riding a car, you have to go to school, you went by car and came back home in the afternoon. So if you take a longer route or whatever route you take, except the straight path between the 2 points. If I simply give you, on a piece of paper, if I give you just 2 points and ask you to draw a line, can anybody draw this? Can anyone draw this? What will you do? That you will always draw this line, isn't it? Shortest line.
yes,
Yes,
Or not?
yes.
So the shortest path is always the straight line between 2 points.
okay, ma'am.
That shortest path between any 2 points is the displacement.
Ma'am, like, does it depend upon the speed we are traveling?
Oh, why it will depend here? This is just the distance. If I go from, if I go to Delhi from Bangalore, I've preferred train to another person who preferred flight. And let's say, although we means it's not so true that plane always take the straight path, some curves. Let's assume that plane just, begin from the Bangalore airport and straight path followed and landed at the Delhi airport. So who takes more time? Obviously train, because the route becomes longer.
Ma'am, what if the train goes in a straight line and the flight goes in a curved manner?
Now it is about, see, then in
Ma'am,
that
it is a race.
it, because that is practically not possible. In that case, we can expect the train also to reach the same time.
Ma'am, like, what is like this displacement here? The train, the train traveling or the flight one, like, which is
What do
traveling in curve?
what do you think is the displacement here?
I mean, I feel like it's the train path, like, which goes straight.
No, my dear. Plane, in the example which I just gave, plane flight is traveling the straight path. Aeroplane.
Okay, ma'am. So like the plane has a it's a displacement.
Huh. Distance can be any. Either means we call distance simply distance. If no if we are not making the things complex, we will call everything distance. But if we want to move in the detail, then we can say the shortest path will say displacement, and distance displacement can also be distance, but every distance cannot be displacement.
Okay, ma'am.
Got it?
Yes, sir.
Note it down.
Ma'am, Charvik has a doubt.
Pardon?
Charvik has a doubt.
I'm not getting, sorry.
Ma'am is saying that Charvik has a doubt.
Okay, Charvik messaged me. Sorry, let me just read it. Charvik, are you considering train also here to follow the straight path? See, practically we do not have a straight way between Delhi and Bangalore. But so if you are thinking that if the train also, is open to follow the straight path and the speed is also same, then it's very clear that both will reach at the same time. Is it okay? And if you are just wondering that train has the actual path, means the longest way, it has to take many turns and a long route to be covered. And if we increase our speed to 150, still the difference in the distance of that straight and the longer route between Delhi to Bangalore has a big difference between distance and displacement, shortest and the long that actual path. Then also train cannot reach. I think so. Should I clear it?
Yes.
Sorry, should I clear it?
Oh, no, ma'am.
Next, we have to do the slope of graph. Please be quick. We can cover the slope today only. See, I'm clearing this. Have you ever heard the word slope related to graphs? Hmm?
Can you repeat what you said?
Have you ever heard the word slope that is related to the graphs?
No, ma'am. No, ma'am.
Like when the distance is more in a less time, the object is slow, right?
I'm not asking slope. SLOPE. Slope.
Yes, ma'am.
Ma'am, slope means like something which is like down thing.
Ma'am, slope is something which is inclined.
Yeah, like
Something which is inclined, great. The basic meaning of slope is this only. Now, how to use this meaning in graphs and why we are studying slopes. So look at this. Slopes are usually, to find out the speed. Like if I say slope has a general formula, delta y by delta x. This triangle I'm calling delta, which means small change. This is just a symbol. Don't take it so complex, okay? Triangle is called delta, which means small change in the value. Got it? Now, on y-axis, we have what physical quantity? Keep telling me, on y-axis, we have which physical quantity?
Distance.
On x-axis, we have
Time.
Time.
as per the formula of slope and combining this with the graphical representation. Can you tell me what distance upon time is like? We have known this formula, and what does this tell us? Distance upon time is a formula for.
My speed.
So, in very simple terms, we can say that slope of distance time graph gives us speed. Now, how to find the slope? Very simple. I said change in y-axis, change upon x-axis. You just have to take any 2 points. Now it depends upon question. If it is asking for the whole journey, like in this graph, I can see the value, the journey begins from this point and ends at this point, means at 20 seconds, if it is, I'm not wrong. Okay, 20 seconds. So if question is asking the whole journey, what is the speed? If it is asking for first 5 seconds, what is the speed? Then take those 2 points. Means accordingly, you can take any 2 points. Final position means final value of distance upon minus initial value of distance upon total time taken between those 2 points. Is it okay?
Okay.
So simply write the formula slope equals speed. Write this also for, for extra information. Slope equals speed equal final position. I'm writing FP. You can write final value of distance. Anything as per your convenience, you can note down. F dot P according to me means final position minus initial position means distance value divided by time taken between any 2 points. You can write in bracket also between 2 points, and those 2 points can be any accordingly what is being asked on the graph. And by putting these values, we can find the slope or the speed of that particular journey. Okay. So can you tell me, suppose, okay, I'll just zoom it out. You write the formula that I've written. Let's say time here is given in seconds and distance is in meter. Find the slope or the speed of between 15 to 20th seconds. Be quick, very quick. Time is almost over. So be quick, please. I can do one thing for you. Find the slope.
Ma'am, what is written after the formula?
Here in the bracket,
Yes, ma'am.
between any 2 points on graph. Slope or speed from 15 to 20 seconds. Find out speed of the object between 15 to 20 seconds from this graph. Be quick. I can just do one thing. On 15 second, I can mark the line perpendicular and the corresponding distance value for this 15-second point. And for 20th second point also, I can do one thing. Now, please tell
Ma'am,
me.
what is the time taken? Should we write 20 or should we
Difference of two, very simple. If we have taken 2 points, I'm asking you, right? Speed between 15 to 20 seconds means from 15 to 20. So,
ma'am, 5 seconds.
So do one thing in the formula, right here, final time minus initial time. That final and initial are for those 2 particular points only that you have to consider.
Ma'am, is it 2 meter per second? 10 40 minus 30 by 5 is
30 divide by 20 minus 50.
Yes, ma'am. I also got 2 meter per second.
Okay.
Ma'am,
Hmm.
like how to find the time taken?
Dear, subtract the 2 values.
Ma'am, but like if it is like how do we know it is exactly at 15? Sometimes it may be at 10 or 0.
Okay.
because it's mentioned in the question.
If the question is telling you between 15 and 20 seconds, you have to draw a line at 15 second and 20 second and take it over the journey of graph and correspondingly look at the distance value. So you have to do these dotted lines with that I'm doing in every graph. This is
Okay, ma'am.
okay, corresponding to 15 second, what was the position of 30? So this blue line in this graph, this only, that's why this gives us the data and shows us what are the values. At this particular time, this distance was traveled. At this particular time, that distance was traveled. Is the slope fundamental clear?
Yes, ma'am. It is clear.
Everyone noted?
Yes, ma'am. Noted. Yes, ma'am.
Okay. Fine, please revise the graphs properly. Okay.
Okay, ma'am.
Fine, bye-bye everyone.
Bye, ma'am. Thank you, ma'am. Bye, ma'am. Thank you.